Hey guys, all right, so you're going to go over how to convert a repeating decimal like this into a fraction. So first you're going to convert, what does this repeating decimal look like? If they don't have a bar notation over it, I want you to know what it looks like. So this obviously is going to be 0.2, the bar notation, okay? Your first step is to make x equal to that number that you see up there, okay? If you want, you can repeat all your 2's. For me, it's easier to repeat my 2's, so that way I can kind of see it. I put like a good 5 amount up there. And you're going to do that, all right? But in bar notation up here, how many numbers are being repeated? You see how it's only over one number? That means you're going to place 1 0 right after that number 1, okay? And you're going to multiply both sides of this equation by this number, 10, okay? So you're going to multiply 10 by here. It's going to be 10x. And you're going to multiply 0.22222 by 10. A trick is to just move your decimal over by 1, because that's what's representing that 1 0. So you got 2.22222. Okay? Now you're going to go back to your original equation, which is 1x is equal to 0.2222222. You're going to subtract it from this right here. I know it's a lot of steps, guys, but it gets pretty easy after a little bit. You want to make sure you align your decimals. So you see how I have 0, my decimal lines up here, and I got 2, 2, 2. There's a dot, dot, dot here. There's a dot, dot, dot here. These are going to cancel out. It should be your favorite part. 2 minus 2, goodbye, goodbye. What are you left with? 2 minus 0 is 2. It's equal to 10x minus 1x is 9x. That's ugly 9. Hold on, let me do that. 9x. You're solving for x. You want to isolate your variable. To isolate your variable, you got to make sure you divide both sides by 9 in this case. You're left with x is equal to 2 9s. So 0.2 repeating as a decimal converts into this fraction right here. Okay? I don't need to simplify 2 9s, so I'm leaving it like that. I think I should give him another example, Tucker. Tucker's next to me in case you guys are like, who is Tucker? Let me give you another one. All right, so if you got 0.213 and there's a bar notation over a 1 and a 3, you're going to write it as x is equal to 0.2. The 2 isn't repeating. The 1 and the 3 is. So you're going to have a 1, 3, 1, 3, 1, 3, dot, dot, dot. Okay? It's going to keep on going. I like putting in a good 3 sets of those numbers. If you want to do just 1, it's up to you.
No, they have to put in 3.
Okay, Tucker said you have to put in 3. All right? Your next step is to identify how many numbers are being repeated. So you're going to look at the bar notation on top. How many numbers are under that bar notation? 2. That means you're multiplying this one by 100, okay? Because there's 2 zeros after that 1. It's either by 10, 100,000, blah, blah, blah. So if there was like 4 numbers underneath here, you would multiply it by 10,000, okay? Right now we're sticking to 100 for now. So you're going to multiply both sides of this equation by 100. So you're going to get 100x here. And remember what I told you in the last slide. By the amount of zeros there are here, you can move your decimal that many times. So if there's 2 zeros, you're going to move this decimal 2 zeros over. Okay? That's going to give you 21.313113 dot, dot, dot. Oh, I should put another one before Mr. Tucker kills me. All right. Make sense so far? Now you're going to subtract it by the original again. The original is right here. So I'm going to subtract this by 1x because there was an invisible 1 in front of a variable alone. Line up your decimals because this will save your life. 0.21313. You see how it lines up? Goodbye. Cancel out what you can. This one is different. You stop right here. You can't cancel out 3 and a 2. Okay, so you're going to actually have to subtract. So 100x minus 1x is 99x is equal to 21.3 minus 0.2 is 21.1. Okay, you're going to divide both sides by 99. 99. Goodbye. You're left with x is equal to 21.1 divided by 99. Who likes a fraction like this? Nobody. You don't like fractions in general, but you definitely do not like fractions with a decimal in it. So you have to get rid of it. By getting rid of it, you're going to move this decimal over once. Whatever you do to the top, you gotta do to the bottom, okay? The invisible number here is not 1, it's a 0, okay? So when you rewrite this fraction, it's gonna be 211 divided by 990. I am 100% sure that you can divide this. Actually, I'm not 100% sure. I'm 99% sure. 211 divided by 990. Guys, I'm doing this in real life time, so I'm actually going to struggle. Hold on. 211 divided by 990. Do you know if I can simplify that?
211.
No, 211 can't be divided by anything.
No.
I'm such a liar. Remember I said I was 100% sure? Psh, I lied. That is your answer, as ugly as it looks. 0.213 repeating turns into this fraction right here. You may be wondering, when will I ever need this in life? Honestly, never again. But you will need it to pass 8th grade.
It matters. It matters what they do in life.
If you want to be a math teacher, you'll need it again. Or if you need math, you will need it again in one class. But again, you will most likely never see this again. Okay. Good talk. You still got to learn it because you still got to pass.